Reinforcement learning in operations and supply chain management. Reinforcement learning, a branch of machine learning, is increasingly being applied in operations and supply chain management to optimize decision making, enhance efficiency, and improve performance. In inventory management applications, reinforcement learning algorithms enable dynamic pricing, optimizing pricing strategies based on real-time demand and inventory levels, maximizing revenue while minimizing stockouts or overstock situations. Amazon employs reinforcement learning algorithms to optimize pricing strategies dynamically based on factors such as demand, competitor prices, and inventory levels. This ensures that prices are adjusted in real time to maximize revenue while maintaining competitiveness. Reinforcement learning models learn optimal inventory replenishment policies by considering demand forecasts, lead times, and cost constraints, ensuring optimal stock levels. Alibaba leverages algorithms for optimizing inventory management across its e-commerce platforms. By considering factors such as demand forecasts, lead times, and supply chain constraints, models help Alibaba maintain optimal inventory levels, reduce stockouts, and improve customer satisfaction. For warehouse management, reinforcement learning algorithms help with order fulfillment by optimizing picking routes and allocation of orders to minimize travel time and labor costs within warehouses. Reinforcement learning is used to optimize warehouse layout and storage configurations, reducing congestion, improving throughput, and enhancing operational efficiency. Amazon utilizes reinforcement learning for optimizing warehouse operations, including inventory allocation, picking routes, and replenishment decisions. Reinforcement learning algorithms help minimize travel time, improve order fulfillment efficiency, and optimize resource utilization within warehouses. DHL utilizes reinforcement learning for automating warehouse operations, including order picking, packing, and sorting. Reinforcement learning algorithms help DHL optimize warehouse layouts, design efficient workflows, and deploy robotic systems for tasks such as inventory management and order fulfillment. In transportation and logistics, reinforcement learning algorithms optimize delivery routes, considering factors such as traffic conditions, vehicle capacities, and delivery time windows to minimize transportation costs and delivery times. UPS uses reinforcement learning for optimizing delivery routes and schedules to minimize fuel consumption, reduce transportation costs, and improve delivery times. Reinforcement learning algorithms consider factors such as traffic conditions, package volumes, and delivery time windows to optimize route planning. The models optimize fleet operations by dynamically allocating vehicles and resources based on demand fluctuations and operational constraints. UPS employs reinforcement learning to optimize fleet operations, including vehicle routing, scheduling, and maintenance decisions. Reinforcement learning models help allocate vehicles dynamically based on demand fluctuations and operational constraints, ensuring efficient use of resources. Production planning and scheduling is facilitated as algorithms optimize production sequences and schedules to minimize changeover times, idle capacity, and production costs while maximizing throughput and resource utilization. Procter & Gamble utilizes reinforcement learning for optimizing production planning and scheduling in its manufacturing facilities. Algorithms help P&G minimize changeover times, optimize production sequences, and improve resource utilization, leading to increased throughput and operational efficiency. It is used to optimize maintenance schedules for production equipment, considering equipment health data, production priorities, and resource availability. DHL employs reinforcement learning for predictive maintenance of its logistics infrastructure, including vehicles, equipment, and facilities. The models analyze sensor data, equipment usage patterns, and environmental conditions to predict maintenance needs, reduce downtime, and optimize asset performance. For supply chain optimization, reinforcement learning models help in supplier selection since it can learn to select optimal suppliers based on criteria such as quality, reliability, and cost, optimizing supply chain performance and reducing supply chain risks. Alibaba optimizes various aspects of its supply chain, including supplier selection, order fulfillment, and logistics operations. The algorithms help Alibaba identify optimal sourcing strategies, improve order processing efficiency, and enhance supply chain visibility and responsiveness. Demand forecasting accuracy is improved by learning from historical data, market trends, and external factors, enabling better inventory management and resource planning. P&G employs reinforcement learning for improving demand forecasting accuracy by learning from historical sales data, market trends, and promotional activities. P&G can better anticipate demand fluctuations, optimize inventory levels, and enhance supply chain planning. Reinforcement learning helps with resource allocation decisions as it can be used to optimize labor allocation and scheduling in manufacturing facilities and distribution centers, ensuring adequate staffing levels to meet demand while minimizing labor costs. Reinforcement learning algorithms optimize energy usage in facilities by dynamically adjusting equipment settings, production schedules, and energy consumption patterns to minimize costs and environmental impact. Risk management applications are getting enhanced with reinforcement learning since these models can learn adaptive strategies for responding to supply chain disruptions, such as supplier failures, natural disasters, or geopolitical events, minimizing the impact on operations and mitigating risks. Reinforcement learning algorithms assist in developing contingency plans and risk mitigation strategies by simulating various scenarios and recommending optimal responses in real time. Ford uses reinforcement learning for modeling and simulating supply chain risks and disruptions. Reinforcement learning algorithms help Ford identify vulnerabilities, evaluate mitigation strategies, and develop contingency plans to minimize the impact of supply chain disruptions on its operations. Multi-agent systems can be modeled and simulated with reinforcement learning. For instance, reinforcement learning is used to model and simulate market dynamics in supply chains where multiple agents, for example suppliers, manufacturers, distributors, interact and make decisions autonomously, optimizing overall system performance. Ford employs reinforcement learning for optimizing supplier relationships and collaboration. Reinforcement learning models help Ford identify strategic suppliers, negotiate contracts, and manage supplier performance, ensuring a resilient and efficient supply chain.